Well, hello everybody. We are starting our next topic, and this topic is area. Area. And actually, as part of this lesson, we're going to need to do some counting in halves and adding halves together. So here I have got some questions about halves for our starter. Here's half a pizza. I've written it 1 half. 1 half. The 1, the numerator, means 1. And out of 2 equal parts. 1 half. And for the starter, I'd like you to say half add a half gives us what? And if a child wrote this, 2 over 2, would that be correct or wrong? What about this? A half add a half add a half. What do we get for that? And a half add a half add a half add a half. 4 halves. What will we get for that? And at the end, I'd like you to tell me what the 4 numbers should be. 5 here. So we have halfway between 0 and 1, halfway between 1 and 2, halfway between 2 and 3, halfway between 3 and 4. Pause the video, have a go at answering our starter questions. Okay, I hope you paused the video. So here's the first question. 2 halves. A half, a pizza, and another half. Well, we can see that if we put them together, we get 1 whole pizza. 1 half add 1 half is 1 whole. But what if a child had written 2 halves like that? Is that right or wrong? What do you think? Well, it is right. Actually, that is perfectly good maths. No problem. 1 is the same as 2 halves, because 2 halves make 1. So, what about our next question? 3 halves. Well, the half and the half make 1, and then we've got 1 and a half. We write it like this: 1 whole pizza and a half pizza. Could we write it 3 halves like this? 3 halves. Yes, we could, because we've got 3 halves. What about this one? A half and a half and a half and a half. Well, half and a half is 1, another half and a half is 2. So we've got 2 wholes. Could we write that we've got 4 halves using a fraction? Yes, we could. 4 halves. Okay. What did you say? Halfway between 0 and 1 is a half. Halfway between 1 and a half, oh, we're counting in halves. 0, 1 half, 1. 1 and a half, 2. 2 and a half, 3. 3 and a half, 4. 4 and a half, 5, and so on. So that's what we're doing. We're counting in halves. Each time it's another jump of a half on. And if we remember our decimals, 0.5, 1. I'll tell you what, let's rub that one out. It's a bit messy up there, isn't it? It's going to be not enough space. 0.5, 1.5 is the same as 1.5. 2.5, 2.5. 3.5, 3.5. 4.5, 4.5. Okay, that's going to be useful for us in our lesson, but we're learning about this very important word, area. I've underlined it here as well. Area. An area is just the word that means how much space or how many squares a 2-dimensional shape covers. So let's look at this red rectangle here. The red rectangle covers how many squares? How many squares has it got inside it? Well, 1 little square. 2, 3, 4, 5, 6, 7, 8. The red rectangle covers 8 squares, so the area is 8 squares. The area of the red rectangle is 8 squares. The black shape covers how many squares? Let's count them. 1, 2, 3, 4, 5, 6, 7. 7 squares. So what's the word? So the is 7 squares. What should we write in the gap? It's a missing word. The area. That's what we're learning about. The area is 7 squares. So we've got to count up the squares, or count the space inside a shape for the area. Area is something when we talk, it's what we talk about when we have two-dimensional shapes. A dimension is a measurement of length. Two-dimensional shapes, we can only measure them in 2 different directions. Here we have the length going across, that we'll sometimes also here called the width, and then the height. Here the length is 3, 1, 2, 3 squares. The height is 1, 2, and a rectangle has area because it is just covering how many squares? Well, 1, 2, 3, 4, 5, 6. So the area is 6 squares. When we look at cuboids, they don't have 2 dimensions. They are 3D shapes. 3-dimensional shapes. They have length and height, just like the rectangle, but they also go back depth. And when we talk about what 3D shapes have, they have something called volume, which we can imagine as if you wanted to fill that cuboid up with water, the volume is how much water it can hold. And we can also think it's how much air it can hold. Okay, back to area. The area of the black shape. Do you remember area? How many squares a 2-dimensional shape covers? Okay, well, we count it up. The area of the black shape is 1, 2, 3 squares, 4 squares, 5, 6, 7. So the area of the black shape is 7. Is that right? It's the right number, but I've forgotten something. When we talk about area, we must say what we are counting. It's a measurement of something. Here, we're counting the squares for the space inside, the squares. Not just 7 squares. The area of the red rectangle, 1, 2, 3, 4. Okay, the first column is 5. Then another 1, 2, 3, 4, another 5. And another 5. 3 lots of 5s, isn't it? 3 times 5, 15 squares. Sometimes we can use multiplication, can't we? Sometimes for these rectangles, if it's always the same number in a row or a column. The area of the rectangle is 15 squares. Now, there's something important for us to know, and it's going back to our starter. The area doesn't have to be whole squares. So look at this red triangle here. I can see it's got some half squares. That's fine. We can still count halves, can't we? So my idea, and how I think it's easiest, is when we've got some whole squares and then some half squares, I maybe would always try to count the whole squares first. So let's look at this red triangle. Say, right, inside it, there's one whole square, there's half here and half here, half a square and half a square. Well, the half and the half is 1, and the other one, which is a hole, so 2 holes. The area of the red triangle is 2 squares. The area of the black triangle, right. We've got to count the whole squares. Well, there's 1 whole square, 2 whole squares, 3 whole squares. That's all the whole squares. 3 holes and a half, another half, and another half. Well, a half and a half is another hole. That's 1. All right, 1, 2, 3. These 2 make 4. 4 and a half squares. Right. So when it's a mixture of whole and half squares, I think it's a good idea to count up the whole squares and then see how many halves you've got. And what is area used for? Well, area can be used for comparing the size of lots of flat 2D shapes. Now, imagine we had 2 farmers comparing fields. We've got field 1 over here and field 2. And the question is, which field is larger? Which field is larger? Which has the greater area? Which has a bigger area? Okay, well, let's answer that question. Field 1. Let's count the squares for the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, field 1, the area is 10 squares. Now let's look at field 2. 1 whole, 2, 3 whole squares, 4 whole squares, 5 whole squares, 6, 7, 8, 9 whole squares. But now we've got some halves. 1 half, 2 halves, 3 halves. So how many whole squares? 9 whole squares. This half and a half make another whole, so that's 10 squares and a half. Field 2, the area is 10 and a half squares. So which field is bigger? Well, is it field 1 or field 2? Field 2, because the area is 10 and a half squares. How much bigger is one field than the other? Well, 10 squares, 10 and a half squares. What field 2 is half a square. Whoops, running out of space. Bigger. And we use area in lots of problems like this. We want to know how much room, how big a room is, how big the floor is, how much carpet we need to put down to cover all of the floor. We might need to know how much space a painting covers on the wall. These are all examples of area. So your work today, you've got this sheet to have a go at, and I'd like you to write the area of each shape beside it. And don't forget, you need to write not just a number, but the number and squares. And when we get to level 2, we've got to start counting some half squares, and there are some challenge questions as well. So I hope you enjoy it, and let us know if there are any problems, and we're looking forward to seeing your work. Okay, bye everybody!